Today's tutorial we are going to discuss about the continuity of a function at a point. So to know the continuity, you must know three things: is that f of x is defined. Second point is limit x tends to c, f of x exists. And third point is limit x tends to c, f of x is equal f of c. So if three conditions satisfied, then f is continuous at x is equal c. So if one of them fail, then it's not continuous. The function is not continuous at c, and then it's not continuous in the whole domain. So we'll discuss various example. So first example we discuss through the graph. Suppose you have this function as described in the graph. So we have to discuss the continuity of this function at different point. So continuity, the continuity of this function need to be discussed at the point 5, the end point, at the point -4, at the point 2, at the point 4, and at the point 5. In other cases, the function is continuous. So when we discuss at 4, so first discuss at x equal -4. So at x equal -4, f of -4, which is this point, is given by 16. So f of -4 is defined. Next, limit. For the limit, we need to check the left hand side limit and right hand side limit. So left hand limit of -4, x tends to -4 minus f of x, which is equal, if you show the graph, so when you come to the left hand side, it's coming to the 5. So this is equal 5. Limit x tends to -4 plus fx. So this together implies limit x tends to -4 f of x do not exist. So this implies f is not continuous at x is equal -4. Our next point is at x equal 2. So at x equal 2, what will happen? So first let's check what is f of 2. F of 2, it's given here. So this is the point f of 2. F of 2, the value is 4. Next, the left hand limit. Limit x tends to 2 minus f of x. This is equal. So when we talk about the left hand limit, this will go like this. So this is equal 4. And right hand limit f of x, this is equal. So this curve is coming is to -3. So therefore the limit is 3. So this 2 implies limit x tends to 2 f of x do not exist. So this implies f is not continuous at x is equal to. So now we'll discuss it about at x equal 4. So first f of 4 which is equal 9 and limit x tends to 4 minus f of x which is equal, so this side which is still go to the 9, limit x tends to 4 plus fx. So this is coming on this curve, so this is equal 9. So this implies limit x tends to 4, f of x is equal 9, which is f of 4. So this implies f is continuous at x is equal 4. Now next case is we will take it at the end point -5 and 5. So let's have just -5. f of -5 it is defined and the value is 5. Okay. And in this case you will take only the right hand limit. So limit x tends to -5 plus f of x. Okay, so this limit, and here is the curve is like this, so this is also going to 5, so which is equal f of -5. This implies f is continuous. First case is at x is equal 5. So in this case we'll see the value. So f of 5 is equal 11, and consider the left hand limit x tends to 5 minus f of x, which is equal, if we see from the graph, it's going to 11. So therefore you will get it here 11, which is equal f of 5. So this implies f is continuous at x is equal 5. That's all from the figure. Piecewise function based on which we will discuss about the continuity. So the question is, what f of x is equal x square minus 4 over x minus 2 when x is not equal to, and a when x is equal to is continuous everywhere. Solution: clearly, being a rational function, f is continuous everywhere except at x is equal to. Now we'll discuss at x is equal to, we have limit x tends to 2 f of x, which is equal limit x tends to 2 x square minus 4 over x minus 2. This is equal limit x tends to 2 x minus 2 x plus 2 over x minus 2. Now x minus 2 cancel out. You will get the limit is equal limit x tends to 2 x plus 2, which is equal 4. Since for the continuity we must have limit x tends to 2 f of x is equal f of 2, we have this is equal 4 and f of 2 is equal a. So this therefore for a is equal 4, f is continuous everywhere. That's all. F of x is equal sine ax over x when x is not equal 0, 5 when x is equal 0. So the question is here, at what value of a the function is continuous everywhere. X not equal 0, sine ax is continuous, x is continuous. This implies sine ax over x is continuous at all x except x is equal 0. Now at x is equal 0, so take the limit x tends to 0, f of x is equal f of 0 if limit x tends to 0 sine ax over x is equal 5. This implies, so what is this limit? We know that this can be written as a limit x tends to 0 sine ax over ax is equal 5. This implies a is equal 5. So therefore at a equal 5, this function is continuous at every point. Find the value of a and b for which f of x is equal ax plus b when minus 4 less than equal x less than minus 2 ax square plus bx plus 3 and minus 2 less than equal x less than 2 and 2x plus 5 when 2 less than equal x less than equal 4 is continuous everywhere. Okay, we'll discuss at x equal minus 2. So at x equal minus 2 you have limit x tends to minus 2 minus f of x is equal limit x tends to minus 2 plus f of x, which is equal limit x tends to minus 2 minus, so in this case we will take the left hand side x plus b. This is equal limit x tends to minus 2 plus f of x is ax square plus bx plus, so you will get it here, minus 2a plus b is equal 4a minus 2b plus 3. So this will gives you minus 6a plus 3b is equal 3. So this will be minus 2a plus b is equal 1. So this is, say, equation number 1. Next, at x is equal to, we have limit x tends to 2 minus f of x is equal limit x tends to 2 plus f of x. This will gives you limit x tends to 2 minus ax square plus bx plus 3 is equal limit x tends to 2 plus is 2x plus 5. So this is equal 4a plus 2b plus 3 is equal 9. So this will gives you 2a plus b is equal 3. So say this is equation number 2. From 1 and 2 we have minus 2a plus b is equal 1, and here we have 2a plus b is equal 3. Now solve them. If you add them you will get it here, 2b is equal 4. So this implies, substitute any of them. Here you will have minus 2a is equal 1 minus b. This implies minus 2a is equal 1 minus 2 is equal minus 1. So this implies a is equal half. So therefore a is equal half and b is equal to f is continuous everywhere. This is the conclusion. So this way we can discuss the continuity of different functions.